Today, we will learn how to use a pre-trained convolutional neural network for image classification using image dataset called Caltech101. First, we need to download the dataset. To do it, go to your web browser and search for Caltech101. Here it is. Now click on Download. This is the dataset. Click here. The dataset is being downloaded. The download is completed. Now copy it and paste it in a folder. It is a zip file, so we need to extract it. We don't need this zip file anymore. We can remove it if we want. I prefer removing it. Let's rename the folder as Caltech101. Our dataset is ready, and we are ready to use pre-trained convolutional neural network to classify the images of this dataset. Convolutional neural network is a powerful machine learning technique. A large collection of images is required to train convolutional neural networks. The larger the collection, the richer the features that CNN learns. These features often outperform features such as HOG, LBP, or SERV. Training a CNN with large collection of diverge images is not an easy task. However, there is an easy way. We can use pre-trained convolutional neural network. It saves a huge amount of time and effort. And this is what we are going to do in this lesson. To keep things organized, create a folder. Let's name it image classification using CNN. Now move the dataset in this folder. Launch your Matlab and locate the folder we have just created. Now the folder is in Matlab's current folder window. We can see the dataset here. Create a new script and save it as classification. You can use any other name. There is no restriction on it. I'm going to load the dataset. There is a function in Matlab called full file. This function is used to create file path. Let's see how this function works. We have the Caltech101 folder. Inside this folder, there is another folder called 101 object categories. Inside 101 object categories folder, there are multiple folders. Let's take airplane folder. Now, if we run the program, the function will return the full path to the last folder. You can see here, the function has returned the path of the folder aeroplanes. I think you have understood how this function works. Now let's take a variable named output folder, and using full file function load the path of the dataset in this variable. Next task is to get the path of the 101 object categories folder. Let's take a variable and name it root folder and use the full file function again. Instead of directly accessing the folder, we can use the output folder variable because the path is already there. We want to get the path of 101 underscore object categories folder. Let's run the program. Yes, we got the path of 101 object categories folder in the root folder variable. Let's terminate it using semicolon so that it doesn't get executed every time we run the program. This folder has 102 different categories. I really want to use all of these categories. However, it is not convenient to use all of them because if we do so, this lesson will be too long to follow properly. My goal is to show you how to use pre-trained convolutional neural network to classify images, and it can be shown using 3 or 4 categories. Let's take 3 categories. Taking a variable named categories, and I like to show airplanes, ferry, laptop category. Now we will create a image data store, in short IMDS. IMDS helps managing data. Because it operates on the image file locations, it does not level the images into memory until they are read. And that's make it efficient to use. Type with me, IMDS equals image data store full file root folder categories level source folder names. Let's run this program and see what happens. The image data store has loaded these images, and the levels are aeroplanes and more, and 945 more. So the images located in these 3 categories are now in IMDS with appropriate level. Let's terminate this line so it does not get executed every time we run the program. Here, the image data store function has two arguments. The first argument is full file root folder, categories. It is the location of the images. The second argument is a name and value pair. Here, the name is level source and the value is folder names. That means the images will be labeled as per their folder names. Now the IMDS variable contains the images and their corresponding category levels. Let's count the number of images in each category. I'm taking a variable named TBL, short form of table, and I'm going to use a function named count each level, and we will count the level of IMDS variable. If we run the program, we can see that aeroplane has 800 images, ferry has 67 images, and laptop has 81 images. The number of images per category is not same. It will create a problem. To avoid problems, let's make the number of images per category the same. I'm going to find out which category has least number of images. To do it, I'm going to use min function. Type with me min set count. It's just a variable name. You can use other name if you want. Min, and the argument of this function will be this TBL variable. This is how the TBL variable is storing data. The first column is the name of the categories, and the second column contains the number of image per category. We want the number of images. That is why we have to focus on second column only, and using this code we are accessing these numbers. That means the second columns. Let's terminate this line and run this code to see what this line does. It's 67. Have you noticed that the least number of image was 67 and this line has produced 67? So we will reduce the number of images per category to 67. Terminate this line. Now we want to update our image data store. In the updated data store, each category will have 67 images. To do it, I'm going to use a function called split each level. This function will split each level located in IMDS variable and will keep min set count number images in each category. You remember, min set count gave us 67, right? And I want to select 67 images randomly. That is why using randomize argument. Terminate the line, and finally I'm assigning this modified data store to IMDS variable. Now, each of the categories of our image data store has same number of images. You don't have to believe me. See for yourself. Let's use count each level again and run this program. Each category has 67 images. Terminate this line, taking a variable named airplanes. Now using find function to find the images located in IMDS data store, which level is airplanes and sequence is 1. Doing the same thing for ferry and laptop category. Now plotting these images, the first image will show the first subplot will show aeroplane's image. The second subplot will show ferry image, and the third subplot will show laptop image. Running the program, and you can see the first image is the image of an airplane, second one is a ferry, and third one is a laptop. Now we have equal number of images in each category. We also visualized the first images of each category. It's time to load the pre-trained convolutional neural network. There are several pre-trained convolutional neural networks that has gained popularity, and ResNet 50 is one of them. It has been trained on ImageNet dataset. ImageNet dataset has 1,000 object categories and 1.2 million training images. We can load ResNet 50 by writing ResNet 50, and we need to assign a variable to it to store the network. Let's take a variable named net. If the ResNet 50 module is not installed in Matlab, these commands will not work. However, don't be alarmed. It is very easy to install ResNet 50. Go to your Home tab, click on Add-ons. The Add-on Explorer will appear. In the search box located on top right corner, type ResNet 50 and click on search icon. Here it is. This add-on is already installed in my computer. That is why it is showing installed. If it is not installed in your Matlab, you will see a install button here. Simply click on the button to install it, and that's it. Let's get back to the coding. So in our coding, the ResNet 50 has been loaded. Let's plot the network to visualize its architecture. figure. Now plot the net, and the title will be Architecture of ResNet PT. Running this code, and we will see the architecture of the network. It seems pretty complex architecture and difficult to understand. We need to resize the figure to understand the architecture properly. To do it, I'm using set function to resize the figure of the network. The first argument of this function is GCA. It loads the current axis. The second argument is ylim. Ylim stands for y limit. The third argument is the region within which we want to limit the figure. I'm limiting the x and y axis within 150 and 170 region. Let's run the program. Now we can understand the architecture easily. This is the input, this is convolution layer, and this is the activation layer, this is ReLU function, and you understand, you got the idea how to see the network architecture. We need to inspect the first layer to find out what type of input it accepts. Different pre-trained CNN requires different image size and type. By inspecting the first layer, we can find out what type of images a particular pre-trained convolutional neural network requires. To do that, type with me net.layers1. If we run this code, we will see the input layer property. You can see the input layer properties here. The name is input 1. It takes 224 into 224 into 3 size image. That means the image dimension has to be 224 into 224, and the 3 represents a 3-channel image, for example, RGB image. Let's inspect the last layer. To do that, type net.layers and run the program. These are the properties of the last layer. The name of this layer is classification layer FC1000. There are 1000 classes. That means this CNN model has been trained to solve a 1000-way classification problem. There is another way of getting the number of classes of a neural network. You can get the number of classes by typing num bracket start net.layers and dot class names. If we run this code, we got the number of classes. There are 1000 classes in this network. One thing I like to mention that we are not going to use this CNN for the original classification task. It is going to be repurposed to solve a different classification task on Caltech101 dataset. To do it, we have to prepare the training and test images. I'm dividing the images of Caltech101 dataset into training set and test set. using a function called split each level, and this function will operate on images stored in IMDS, that means image data store. I want to use 30% of the image for training and rest of the 70% image for validation, and I want to select the image randomly. That is why using randomize at the end. Terminate the line. I mentioned earlier that different CNN accepts different image dimension. That is why we need to perform a little image processing before sending them to CNN. The ResNet 50 takes 224 by 224 3-channel images as input. Let's get the required size of input image. net.layers1 dot input size gives us the required size of input images. Let's store the size value in a variable named image size. I'm removing the semicolon and running the code to see the size. The required size is 224, 224, 3. Now bringing back the semicolon to terminate the line. Many engineers mistakenly overwrite the source image while processing. To avoid such mistake, let's use augmented image data store to resize and convert any grayscale image to RGB image on the fly. There is another benefit of augmented image data store. It can be used for additional data augmentation when used for network training. The first argument is the size of the image. The second argument is set of image. We want to perform the image processing on the training dataset first. Training set. We need the color pre-processing argument to convert gray image to RGB image. The line is pretty long. Let's break it down. Now our training dataset will be resized according to image size, which is the required input image size of ResNet 50, and the grayscale images will be converted to RGB color image. Let's do the same thing for our test image. To do that, simply change the variable name, then the image set name. Here this test set is coming from this test set, and here this training set is coming from this training set. Each layer of a convolutional neural network produces a response. However, not all of the layers are suitable for image extraction. The layers at the beginning captures basic image features such as edges and blobs. We can see these features by visualizing the network filter weights from first convolutional layer. This can help you to understand why the features extracted from convolutional neural networks work so well for image recognition. Let's get the weight for second convolution layer. W1 equals to net dot layers 2 dot weights. This line is getting the weights of second convolutional layer and storing it in W1. Here W1 is a matrix. To visualize it, we need to convert it to image. Using Matlab's mat to gray function, we can easily convert the matrix to image. Just put W1 as the argument of mat to gray function, and it will convert W1 from matrix to a grayscale image. Storing this grayscale image into W1. Plotting W1. Title is First Convolutional Layer Weight. Running the program. And you can see the weights of the first convolutional layer. These features are processed by deeper network layers which combine the early features to form the higher level image features. These higher level features are better suited for recognition tasks because they combine all the primitive features into a richer image representation. Using activation method, we can easily extract features from one of the deeper layers. We can choose any layer, however, I prefer extracting features from the layer right before classification layer. In ResNet 50, this layer is named FC1000. Let's extract the features. The name of the feature layer is FC1000. Let's take a variable named training features, and now using the activation method, it will be applied on ResNet 50 neural network, and the image dataset is augmented training set, and we are interested in feature layer, that means FC1000. The mini batch size is 32 and we want the output as columns. It's a pretty long line. Let's break it down. The activation function automatically uses GPU. However, if GPU is not available, the CPU is used. Here, the mini batch size is set to 32 to ensure that the CNN and the image data fit into GPU memory. If your GPU run out of memory, you may need to lower the mini batch size. The activation's output is arranged as columns. This type of columnar output speeds up the multi-class linear SVM training. Now we need the levels of the training set, and I'm doing it using this line. To train the SVM, I'll use a function called fit class error correcting output codec, in short fit CEOC. It's a strange name but a very powerful function. It returns a full trained multi-class error correcting output codec model. This function uses k into k-1/2 binary support vector machine models using 1 versus 1 coding design. Here, k is the number of unique class levels. The first argument of this function will be training features. We extracted the features earlier, you remember, right? The second argument will be the levels of training images. We stored the levels in a variable named training levels. Training level. The learner of this SVM will be linear classification. Instead of default 1 versus 1 coding, we will use 1 versus all coding, and our observations will be in columns. It has become a pretty long line. Let's break it down. I mentioned earlier, this function returns a trained model. So we need a variable to store the model. Let's call this variable classifier. You can use other names. You are totally free to do it. Now we will evaluate the classifier. To do that, we have to extract the features from test set, and we know how to do it. We have done it earlier in this line. Why don't we copy this line and paste it? However, we have to change the variable name here. Let's rename it as test features, and we have to change the name of test set. We're going to extract the feature of this test set. So copy the name and paste it here. This line will give us the features of test image. Using these test features, we can measure the accuracy of the trained classifier. If we pass the test features to the classifier and compare it with obtained features, we can calculate the accuracy of the classifier. To do it, we have to use predict function. The predict function returns a vector of predicted class levels based on trained classifier. We have already trained our classifier. Remember? This is our classifier. So write it down. Classifier. The features the predict function will use are stored in test features variable. Write it down. And our observation will be in columns. We need to assign a variable to this function to store the levels returned by this function. Let's create a variable named predict levels. We will have the predicted levels in this variable. To compare the result, let's get the original levels. For that, write test set dot levels and assign a variable to it. Let's name it test levels. So we have the predicted levels in this variable and the actual levels in this variable. Now we can use a confusion matrix to evaluate the performance of the classifier. In Matlab, we use confusion mat function to generate the confusion matrix. The first argument of this function is the known value. In our case, the test levels are known. So copy the name and paste it here as the first argument, separated with a comma. The second argument is the predicted value. In our example, the predicted values are predicted levels. Copy it and paste it here as second argument. I'm removing this semicolon to see the confusion matrix. Now running the program, you see this system is working. It will take a while. Here is the confusion matrix. Let's assign a variable to this function to store the confusion matrix. We can use any name. I like to call it confmat and terminate this line. When we are evaluating a classifier, we expect a percentage value, and there is an easy way to generate the percentage value from this confusion matrix. We can do it by using a function called bsxfun. The first argument of the bsx function represents the operation. We're doing division here, so write at our divide. We want to divide the confusion matrix, so write confmat here, and we will divide the confusion matrix by this. It is a single column matrix. Instead of explaining, let's see what this matrix is really doing. Copy this section and paste it here. Now run the program. Matlab is running. This is the output from this line. What it actually did is it calculated the sum of entire row of this matrix and put the value as the first element. Here the first element is 47, and this line did the same thing for each rows. I'm going to remove this line because we don't need it anymore. Now let's see what this bsxfun function doing. For that, remove this semicolon and run the program. The program is working and it will take some time. The bsxfun function has generated this matrix. What it actually did, it converted the value of confusion matrix into percentage. This is 100%, it represents 100%, this is also 100%. Now, if we calculate the mean value of this matrix, then we will get our percentage accuracy. And notice carefully that this matrix has value diagonally. So to calculate the mean value of this matrix, we have to use the Matlab's diag function. So let's see how to do it. First, store this value in confmat variable and terminate this line. Then we will use the min function of Matlab. Inside it, we'll use diag function and it will be applied on confmat matrix. Let's run this program. Here is the accuracy. The accuracy is 0.9929. That means the classifier for this test set is 99.29% accurate. Now it's time to classify images. Before that, let me terminate few lines. Now I'm going to comment out the subplots because I want to show the classes only. I don't want to show any figures. I'm done. Remember, we use three categories: airplanes, ferry, and laptop. That means we can categorize images of airplanes, ferry, and laptop. Let's download an image of an airplane. Go to your web browser, search for airplanes. Go to image, pick up any image. Let's take this one. Save it to your working directory. Let's rename it Test101. You can see the image in current folder window. Now we need to load this image in Matlab. We know how to do it. Take a variable, new image, use imread function, then use the full file function to get the path of the image named test101.png. Now we need to process this image so that we can send it to the ResNet neural network. And we know how to do it. We already have done it. Let's just copy and paste it here. We need to change the variable names. Let's call it ds. And we need to change the name of the test set. Here the image is new image. This image is representing this image. Now this image has been processed to use in our system. We need to get the image features now, and we know how to do it. We already have done it. I'm simply copying it and pasting it. We need to change the variable name. Let's call it image features. And we need to change the name of image set. The name of our image set is ds. This ds is representing this ds. Now using predict function, we can compare the features and predict the class. We already have used the predict function. Why don't we copy and paste it here instead of typing? We need to change this name because our features are now stored in this variable. Let's copy the name and paste it here. And we need to change this variable name. Let's rename it to level. Finally, using the printf function to find out to which class the loaded image belongs to. Let's run the program. You can see the loaded image belongs to airplanes class. Great. Let's download an image of laptop. I'm taking this one, saving it in the working directory as test102. You can see the image in Matlab's current folder window. Changing the name of the image and the extension because it's a JPG image. Running the program again. You can see the loaded image belongs to laptop class now. The test102 is an image of laptop. So our system has successfully classified the image. Now let's download an image of a ferry. take any of the image you want. I'm going with this one, saving it as test 103. You can see the image in Matlab's current folder window. Change the name from here and run the program again. And here it is. The loaded image belongs to fairy class. That means the image has been classified as fairy. And this is the end of this lesson. If you find this lesson helpful, please subscribe, and I'll be very happy if you share this video and leave a comment. Thank you for watching.